All right, we'll get started, and we're going to talk more regular expressions, and I hope to wrap everything up. Um, this has 104 slides, so we'll see what we get through. Well, it's 104 like buttons of clicking right. Some of the slides, like the way that you do like incremental bullet points, is like it creates a new slide. So that's just the PDF way. It's not a PowerPoint, so it's probably really only 40 slides, but 104 like button clicks. Okay. All right, so we left off on Wednesday. We just talked about these character classes. We said, you got these square brackets, right? The square brackets represent one character, but you can put in a range of characters, right? So you can say 0 through 9, and that is going to be any digit between 0 and 9, but it's only going to match 1. And we have shortcuts for some of these character classes, right? So you have //d, which is exactly equal to square bracket 0-9, okay? And then //D is exactly equal to putting the caret here, so saying anything that is not a digit, okay? And similarly, we have stuff for white space and non-white space, white space and non-white space, and then the W's are for word characters and non-word characters. And word characters are the 52 letters, I guess the 26 letters, capital and lowercase, plus the digits 0 through 9, plus underscores. So things that you create like a username out of, right? So when you sign up for an email address, these are probably going to be the accepted characters that you can use for a username, okay? And then the white space, there's all of these different things. There's the new line and the carriage return, which feels silly, but if you think about a typewriter, the new line is, pushes the paper up a notch, and then the carriage return is, as you're typing, it slides to the right, and then you have to kind of push the carriage. I don't know if you think of the old school typewriters in the movies, but that's what it is, okay? Tab and vertical tab and just the regular old space. All right, so let's take a look at this. You tell me. So string detect returns true or false if it detects this pattern anywhere in the string, okay? It doesn't mean that the entire string has to be that pattern, just if it detects this pattern anywhere in the string. So what is this? P//D, so P followed by a digit. So what is this going to return? It's going to return false, false, false. This is true, false, 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 all right? The only thing where it's true is this one, where it's P followed by the digit 0. Okay, here is P followed by anything that's not a digit, okay? So we're going to get basically just the opposite of this. It's going to be true, 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 false, true, 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 right? All right, here's a pattern. P followed by a non-word character. So a capital W means non-word. So lowercase means that thing. Lowercase d is a digit. Capital D is not a digit. Lowercase w is a word character. Capital W is not a word character. So P followed by a non-word character. Okay, so where will this be true? It's gonna be true for what? Pan? No, no, no. P0N, is this true or false? So it's P followed by a non-word character, okay? So P followed by a 0, is 0 a non-word character? No, 0 is a word character, right? Word character is the letters A through Z, capital and lowercase, plus the digits 0 through 9, plus underscore. So P is followed by a word character, it's going to be false here. P is followed by a dot, that's true. Dot is a non-word character, so it'll be true here. P is followed by A, P is followed by W, it's going to be false for everything else. Okay, false, 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 true, false, false. Is that all right? You can, as you go through the slides, you can always kind of just pause here and just say, what is it going to produce? All right, so these are kind of set up so you can quiz yourselves. Okay, there's also something called a POSIX character class, and this kind of, you put in like words and stuff, okay? So like alnum, like alphanumeric is this, alpha is this, digit, lower, upper, space, things like that, okay? So you have some of these options. Okay. All right. For POSIX to work in R, you got to do double square brackets. Okay. So so this is going to be double square bracket alpha. So anything that has a letter, so it's going to be true for everything, right? Anything that has a digit, if it detects a digit, so it's going to be true for P0, it detects the 0, and here it detects the 3, okay? And so it's going to be true there, false everywhere else. Okay. All right, we have anchors. Anchors are basically kind of referring the pattern that we're going to put in relative to some position, okay? So you might have a line and it's going to either be at the start or end of the string, and you can do, so the caret takes on multiple meanings here. Caret is going to be start of the string, $sign is the end of the string. Or you can do /A for kind of the start and /Z for the end, okay? And then you have B and capital B for word boundaries, okay? Basically, a word boundary is the edge of a word, okay? The edge of a word. So let me just show you, okay? So here is just, we're going to replace any instance where we find the pattern THE, and here, okay? And the text is, the quick brown fox jumps over the lazy dog, okay? And I purposely put in dog twice there, okay? And so this is going to replace any instance of THE, which is going to be right here and here, and we get dash quick brown fox jumps over dash lazy dog, okay? All right, the next thing is I put a caret in front of THE, and so this is only going to match at the start of the string, okay? So what will it result in here? Okay, so will it replace this THE here? Yes. Will it replace this one? No. Okay, and that's what we get. Okay, dash quick brown fox, so and so. Okay, what about here? I've got //A THE. Okay, so the //A is equivalent to the caret, so it's going to give us the exact same result. Okay, and here I've got THE with a $sign, so it's going to match THE only if it's at the end of the string. Okay, so is it going to replace this the? No, what about this one? No, it's going to replace neither, so nothing gets replaced. All right. Here is dog, and with DOG, it replaces both instances because there's no anchors placed here. Here, if I put DOG $, it's only going to replace the DOG at the end of the string. Okay. All right, here is, we're just replacing all word boundaries with a dash, okay? All word boundaries with a dash. So I've got words, jump, jumping, umpire, pump, umpteenth, and lumps, okay? And so it's going to replace a word boundary which is currently invisible in here, and so the result is going to be a lot longer, okay? So it puts, it identifies where the word boundaries are. We got, basically the edges of the words get dashes around them, okay? So it doesn't replace the spaces, okay? The spaces are not word boundaries. The spaces are space characters. But between the space, between the S in words and the space, there is a word boundary, okay? And we are just making that word boundary visible with this, by putting the dash there, okay? Between the space and the letter J in jump, there is a word boundary, and we're making it visible using this. Yeah?
Are dashes the new word boundaries then?
Let me think. Yeah, there might, like if I ran this again on this text, I'll probably end up getting 2 dashes everywhere type of thing, okay? So yeah, word boundaries basically, you know, when it sees the edge of a word, so either, or is it, okay. I'm trying to think if, so the dash, I'm not sure if the dash is considered part of the word or not. I don't think it is. I think only word characters, the letters, the digits, and the underscores are considered part of the words, and so I think it's going to treat the dash as a punctuation. I gotta think this through, or just try out some test patterns with this.
You couldn't have a dash. You can't define an object name with a dash. It has to be under.
Right. So I think, so the word boundary now exists between the S and the dash here, okay? And so if I put in like, replace the word boundaries with like $sign or something. It'll put it in between the S and the dash, I'm pretty sure, okay? Similarly, I can say replace all the non-word boundaries with dashes, okay? And so it looks the same, except it's a capital B, right? So the regex kind of has this pattern where the lowercase letter is the thing you're talking about, and the capital letter is the opposite. So lowercase b is the word boundary, capital B is a non-word boundary, okay? So the non-word boundaries exist between the characters of words. So between the W and the O, there's a non-word boundary. Between the O and the R, there's a non-word boundary, okay? Between all these letters. There is no there's a word boundary between the S and the space, but then there's non-word boundaries between the J and the U. Does that kind of make sense? All right, and so this is what it looks like, okay? It looks like we just kind of put dashes between everything here. All right? Okay, so I've got words, jump, jumping, umpire, pump, umpteenth, and lump, and the pattern I'm searching for is //b, word boundary, UMP. Okay, so this is the hardest part about reading regular expressions, is that the letters look like our eyes are trained, and when we see this, we think we're reading the word bump, okay? But it's not. It's word boundary followed by the characters UMP, okay? So what is going to get replaced? Which words will get UMP replaced with a dash? Umpire and umpteenth, okay? And so we get umpire gets replaced with a dash, the ump and umpteenth gets replaced with a dash. Okay? What about this? // B UMP. Which which words with UMP will get the UMP replaced? Jump, jumping, pump, and lumps, okay? Exactly. Jump, jumping, pumps, and lumps. Those UMPs get replaced. All right? UMP followed by a word boundary. Which ones will get replaced? Jump, pump, and that's it, okay? UMP followed by a non-word boundary. Jumping, umpire, umpteenth, and lumps. All right, is that okay? All right, so let's just kind of revisit this caret thing. What's the difference between this, this, and this? Okay, so this represents digits 0 through 9, where? At the start of a string, right? The caret outside of a thing is the start of a string. This represents anything but the digits 0 through 9, okay? Because caret inside a character class means not that thing, okay? Well, if the caret's at the start of the inside of the character class, okay? And what is this? The digits 0 through 9, or the literal caret, okay? Because the caret here is not at the start, so it becomes the literal caret thing, okay? And so that's what all of this is. So it's hard, okay? Well, so, you know, like I've been working with regular expressions for several years, so I'm like, oh yeah, this makes sense, right? But, you know, it's kind of like, you know, if you're learning English as a foreigner, you know, you've got like, you know, why do we spell some words like I before E, and then other words are not spelled that way, and you got all these like weird rules that, you know, as a native English speaker, and okay, no one's a native computer programmer speaker, right? But after certain years, you gain fluency, right? And that's the point. So, you know, in the beginning, when you're learning all of these things, you're learning a foreign language, right? Like, why do they conjugate it this way? Why does this, that? And there's it seems like there's all of these exceptions, okay? And it can be frustrating, right? But if you say this is important, right? You meet someone you like that speaks a foreign language, so you try to learn that foreign language, right? You're gonna do well, right? But then if you say, well, you know, I don't like this person anymore, you know, I give up, then and you never use it, you forget everything that you've learned. Similar with regular expressions. If you don't use this, or if you don't use your R or whatever for a long time, you're gonna forget all of these little weird exceptions. You'll just be like, oh yeah, I remember there were weird exceptions, but I forgot what they were. I don't know. Somehow life lessons from regular expressions. Okay. Quantifiers, okay? These are useful, okay? So I think earlier we had an example where I said, like, how do you identify 3 adjacent digits? And we said bracket 0-9, bracket 0-9, bracket 0-9, okay? So quantifiers are basically shortcuts for that. So instead of saying bracket 0-9 and you repeat that 3 times, you can just, now we have the shortcut for bracket 0-9. We got //d, okay? We got /d, and then we can do curly brace 3, which means I want 3 of those things, right? So you can say I want exactly 3, I want 3 or more, or I want between, 3, 4, or 5, okay? And then you also have these other expressions. You've got a star, which means 0 or more. A plus means 1 or more, okay? So 0 is a weird thing, okay? And we're going to see some weird behaviors when you say match 0 of these things, okay? And then the question mark means 0 or 1. Basically, it means this character that we're talking about is an optional character. And it can exist in the thing, or it might not, right? Might not would be 0 matches. And if it does, it's going to be a match, a 1, okay? And then the plus is 1, definitely has to be, and there could be more, 1 or more, and then the star is 0 or more. All right, so here I've got words or numbers, this and this and this, okay? Words or numbers 9,876, and combos 1, 2, 3, like password _ 1, 2, 3, 4, and we're going to say replace all instances of this pattern, which is just any white space character, with a dash. Okay, and I do that, and it replaces all the spaces with dashes. Okay, no surprise there. Here I say replace anything that is not a white space character with a dash. So what's going to happen there? So we are going to get a string that is the same number of characters as this, except all the spaces will remain spaces, and anything that's not a space will be replaced with a dash. Remember, this capital S matches 1 character at a time. 1 character that is not space, and it's going to say 1 character that's not a space gets replaced with a dash. And so we're going to get this. So each character that is not a space gets replaced with a dash. Does that make sense? Okay. And it replaces the comma. Okay, so 9,876 gets replaced with 5 dashes, because that comma gets replaced as well. All right. Now I say non-space plus. So the plus means 1 or more non-white space characters. All right. So now the entire words, W-O-R-D-S, all 5 of those match this pattern, okay? They are non-white space characters, okay? All the way up to here matches that pattern, and so that entire pattern, being W-O-R-D-S, which matches this, will get replaced with a dash. The space does not, so the space remains a space. The entire character, O-R, both of those together match this pattern. So what we're going to get here, what will we see? It will be dash, space, dash, space, dash, space, dash, space, and it will look like this. All right? Does that make sense? The difference between this without and with the quantifier plus, and why all of these get just replaced with a single dash. Okay? Here I'm going to replace any word thing, so //w is a word character. Remember, word characters are the letters, the numbers, and underscores. So how is this going to differ from this? Is it going to be exactly the same, or is it going to be different? So it's got a //w plus, meaning one or more. How will these two things be different? String replace all, non-white space with a dash, non-white space plus with a dash, and /w. Yes?
Is the comma considered a word character?
The comma is not considered a word character, so the comma will remain. So that's exactly what we're going to get. We're going to get something that looks quite similar, except 9,876 gets replaced with a dash, comma, dash. Okay, the 9 gets replaced with its own dash. That's one match, and then the 876 matches this separately and gets its own dash. Is that okay? All right. Here is just one digit, okay? Every digit just gets replaced with a dash, so it looks like that. The dashes get replaced. I mean, the digits get replaced with dashes. Here I've got any non-digit, capital D, gets replaced with a dash. So, so W will get replaced with a dash, O will get replaced with a dash, because these are just matching one character at a time, right? Oh, and I'm sorry, and the spaces also get replaced with dashes, okay? The comma and all of that. Okay, and then here I say any digit plus, so /D plus. So what will this look like? It'll be words or numbers, and then it'll be dash, comma, and instead of 3 dashes here, it'll be dash. Okay, and then instead of combos with 3 dashes, it'll be just one single dash, and with password underscore, instead of 4 dashes, it'll be one single dash. Okay, because it's matching one or more digits together. And then one or more non-digits, basically it's going to collapse all of these consecutive dashes, will just get replaced with a single dash. Okay, this almost looks like a phone number now. Okay. All right, so here's kind of some weird stuff. All right, here I put /D question mark. Question mark means match 0 or 1. 0 or 1. All right, so what it's gonna do, all right, is basically, you can imagine there are word boundary, invisible word boundary, I don't know, characters, I don't know if that's the right thing to call them, but those would be a 0 match. There's no digit there, okay? That's a 0 match, and so they all get replaced. So the zeros in between, there's a 0 character, 0 digits between T and H, so that gets replaced with a dash, okay? And so we get this, and then the digits 310 each get replaced with a dash, and things like that, okay? Yes?
So the space is considered?
It's not. Yeah. So there's 0 matches between the E and the space, and so the whatever's between E and the space gets replaced with a dash. The space does not get replaced with a dash. There's 0 match between the space and the Y, and that gets replaced with a dash. Okay, the question marks, you generally wouldn't do something like this, okay, where you replace something with a question mark with a dash. The question mark is useful for within a pattern. You want to say this character or set of this character is optional, okay, and I'll have an example later. Yes, question?
Why did boundary not get replaced for like capital E? Right, for like not digits, boundaries didn't get replaced.
Because we said, well, because there's no question mark there. It's not a, sorry, the question mark is a 0 match. Is it? It only matches if there's a 0, okay? And so I'm kind of using the question mark in probably a way that it wasn't intended, okay? It makes sense if you study this thing, but the capital D, like if I did it with a capital D here, we would get a similar result, okay? If I did a capital D question mark. I don't know, I don't have an example right here at the moment, but you can try it out, okay? You can take any of these things, paste it into your computer, and try it out. All right, here we're going to do a digit, and we've got the quantifier 3. And so we're going to say 3 adjacent digits, and it reads left to right. So, as we go, it's going to say 199, that's a match, and it replaces with a dash, okay? So it reads from left to right, and then so the 6 is, so the 199 gets replaced, and then the 6 no longer matches the pattern, okay? Similarly, so 310 gets replaced, 123 gets replaced, and again, here in password underscore 1234, 123, it reads left to right. 123 matches, and it says that's a match to 3 digits in a row, and it gets replaced with a dash. Okay, and so that's why you get, the 4 left over, and this single digit is not a match, so it doesn't get replaced. Now I can say anywhere from 2 to 4. Okay, so here 1996 is a match, so that entire thing will get replaced. 1234 is a match, so that entire thing will get replaced with a dash. The 5 is not a match because there's only one character by itself, okay? So those numbers get replaced with the dash, and the 5 does not match. All right, I know it's a lot of stuff, but are we doing okay? Okay. My first 2 rows are doing okay. All right. All right. When you use something like the star or the plus, they are by default greedy, okay? They are by default greedy. You have to add a question mark, okay? So the question mark is versatile. Question mark means 0 or 1, but then question mark in conjunction with the star means non-greedy star, okay? And you're like, what is this greedy, non-greedy business, right? So basically, here I say capital P followed by any character. The dot is any character, including spaces and commas and punctuation, any character except a new line, okay? So it's going to go capital P, any character, and any number of those characters, anywhere from 0 to infinity, followed by an R, okay? And it's going to try to, by default, the greedy matching will do as much as it possibly can. So what will this extract? So extract means find this pattern and pull the entire pattern out. So we've got Peter, Piper picked a peck of pickled peppers, okay? So where we're gonna start, okay, and the capital P here matches, so it starts there, and then the E is gonna be part of the dot star, the T is part of the dot star, the E is part of the dot star, R is the space part of the dot star. Yes, okay, the dot matches any character except a new line, okay? So it matches spaces and matches other things. Will it match this capital P? It keeps going, and it stops at this R down here, at peppers, the R in peppers, okay? This matches all of it, okay? So it doesn't match the S, because that's not part of the pattern, right? The pattern says start with a capital P, and end with an R, and it's greedy, so it tries to maximize how much it can extract. Yeah?
Can you explain again the part of the question mark?
Yeah, I will have an example with the question mark, which I think will make it better. Yes?
So it's greedy in the sense that it's not going to reset.
Yeah, right. So it hits this R, so I'll show you the example, okay? Here, I make it non-greedy. I do dot star question mark, okay? Dot star question mark says, as soon as this is fulfilled, stop, okay? So greedy says, keep going as long as you can, where this pattern still kind of counts as being a valid match, okay? And then non-greedy says, as soon as you can stop matching the pattern, stop, okay? And so when I do this, this will pull Peter, okay? Because it says P and then dot star, the E counts, the T counts, the E counts, and then the R, and goes, oh, the R count matches here, and this is a complete pattern, and we're going to stop. Yeah.
So if you wanted it to go through to the R and then it hits that R and then it kind of restarts looking.
Yeah. Then well, okay. So extract is fulfilled at the first match. It finds the first match and it stops. Okay, so as soon as it finds the match, it stops. Okay, if you want to reset and keep continuing, you have to do string extract all, and I think that is my next thing. So I got string extract all. Okay, and so again here I've made it ungreedy. Okay, and so I think this is going to do what you have in mind. And so what will this match? So it'll match Peter, and then it resets and it continues looking for this thing. And so then it will get Piper as well, and then it will stop because there's no more capital P's left. Okay. And an interesting thing is string extract all returns a list. Okay. And there's a good reason for that, right? Because what I have here, I just have one vector, a vector of length 1, but I could have a vector of length 5. Okay, and so string extract will just do the first one, so it will return a vector of length 5. If I have a vector of length 5 strings, it will search for the pattern in all 5 and return a vector of length 5. Here, because I have a vector of length, if I have a vector of length 5 and I say extract all, some of them might return like 1 match, some might return 3 matches, some might return 0 matches, and in order to accommodate different length matches, it creates a list. Okay. All right. Okay. What about this? I've got a capital P or a lowercase p. I've got a character class, and say you can match a capital P or a lowercase p dot star question mark, so an ungreedy dot star ending with an R. So what will we get? So we will get, Peter matches and it stops because it's ungreedy. Piper matches, so it stops and it's ungreedy. And then what's it going to get next?
Picked a peck of pickled pepper.
Yeah, so will it get picked a peck of pickled pepper, or will it get pepper or just per? Okay, so the thing you have to remember is it reads left to right. Okay, so it's gonna reading left to right, right? Because you might say like the most ungreedy thing we can get would just be PER, right? But it's not gonna do PER. It's gonna do picked a peck of pickled pepper because it starts reading left to right. So as soon as it picks up this lowercase p, it says, okay, I'm on a roll here. I got started. All right, this matches, and then it finds this R here and it ends there. Is that all right? Okay. All right. Oh man, okay. It's 2:40. All right, grouping and capturing. All right, we're gonna have to figure something out here. All right, so we can create these capture groups, okay? And putting a question mark colon makes it a non-capture group. Let me just kind of show you some examples here, okay? So basically you're finding a pattern, okay? And then you put something inside this capture group and it kind of gives it special treatment and it pulls it out, separates it out, okay? This also allows you to say this word or this word or this word, okay? So I've got MRS or MS or MR, okay? So find the match MRS or the match MR or the match MR or MS or whatever, okay? You can set kind of, this is different from a character class which matches only one character. You can match like entire patterns here using, but have it like this word or this word or this word, right? So that's the grouping is useful in that sense. And then you can back reference them using /1 and /2. Okay, so so here we're going to just match B, C, D, E, F, G, H, I, okay? And with the match, it says, because these are in parentheses, the B, C, and the D, E, F, it separates those out. Okay, it says this is the entire pattern portion of the pattern that matches, and then it's going to extract the BC and the DEF. Okay, and then here there's no match because it ends in a capital I, so it says there's no match. Let me here is, I've got Mr. Smith, Mrs. Lee, Ms. Garcia in one string here, and we're going to do a match all. Okay, and it matches the MRS, okay, the MR in Mr. Smith, the MRS in Mrs. Lee, and the MS in Ms. Garcia. Now, it gives preference reading left to right. So if I ordered this MR, MRS, MS, what happens with Mrs. Lee here, okay, it finds the MR and it finds it as a match, okay, because MR is listed before MRS. Okay, so it's going to match MR before it matches MRS. And so when you use the ORs, you've got to be kind of sure that you're not getting like a subset of the other thing, okay? And you have to put it in the correct order. So if you get an MRS and an MR, you have to put it in this order. Otherwise, it will always pull out the MR here, okay? Compare this versus this. This is just a shortened example. I could just say the R's match the capital M, and then the R is optional and the S is optional, and it will match MR, MRS, or MS like that as well. Okay. Here, we're saying match the title, Mrs., Ms., or Mr., the literal dot, a space, and any number of word characters. Okay. And the word characters are in its own captured group. So it's going to go through and it's going to match all of these, and it extracts out the title, Mr., Mrs., Ms., and it also extracts out what matched this word character one or more, and it gets the Smith, the Lee, and the Garcia, and it extracts that out separately. Okay? And so capture groups are really useful in this regard. Is that okay, what's happening here? Because I put parentheses around this /W plus. Okay, so you might say, well, I'm not interested in the title. I only want the last name. Okay, and so I modify this and I just put in the question mark colon. This means this is a grouping thing, which is useful for getting the different kinds of titles because I want this or this or this. Okay, but I don't actually want to save that. I only want to save the last name. Okay, and so I put the question mark colon there. And it doesn't separate out the title, and it just pulls out the last name there. Okay. Back references. You can refer to the things you captured. Okay. This thing becomes known as reference 1, this capture group, and this thing becomes reference group 2. So what it's going to do is, when I do the match, it's going to say, okay, we've got George and we've got Washington. John becomes 1, Adams becomes 2, Thomas becomes 1, and Jefferson becomes 2. This gets useful when you want to run something like a replace. You can replace all of this text with 2, 1, which is going to swap the order of the last name with the first name. And so when I run the replace on this, it gives me Washington, George. And then, because I put 2, space 1, semicolon. And then John Adams becomes Adams, John, semicolon. Thomas Jefferson becomes Jefferson, Thomas, semicolon. So that's a back reference here. Here's an example. I've got a word boundary followed by a capture group of one or more word characters, any number of space characters, and then back reference 1, the thing that I just captured, followed by the group of text that was captured earlier, followed by a word boundary. All right, what is this going to do? Okay, it's doing, right? It's like translating from a foreign language, okay? So we're looking at the quick brown fox jumps over the lazy dog, okay? And what it's going to do is it's going to find repeated words, okay? Because so it says, find the word boundary, the matches this, and then there's a space, and then the word the gets repeated again here, and that means it's got to match this /1, means basically what was captured here has to appear again. So it finds the, and then the capture, the word that was repeated is the. All right, so here, kind of putting a bunch of this stuff together, I've created a telephone number example, right? So if we want to search for telephone numbers in some on the internet, right? And there's not like in the US, you have a 3-digit area code, a 3-digit prefix, and 4 digits afterwards, right? So you say 310-825-8430 or something like that, okay? Sometimes you put parentheses around the area code. Sometimes you separate things with dashes or spaces or dots, or you don't, you just write all 10 digits all together. And so here we say literal opening parentheses, but we make it optional with the question mark, okay? Then we create a capture group. This is the opening and closing regular parentheses, not escaped. And the area code has to start with a digit between 2 and 9. You can't have an area code that starts with a 0 or a 1. That's kind of rule in the US. Okay, followed by any 2 digits, closing parentheses, and then an optional literal closing parentheses by making / parentheses question mark. Then I have one of a character class of either a dash, a space, or a dot, and I make that optional. And then the prefix, again, can't start with a 0 or 1, so we say 2 through 9, followed by 2 digits, then a delimiter of either a dash, a space, or a dot. And then we make the delimiter optional, and then we have / D4, okay? And so here's a bunch of text. I've got Apple, 1-800-786, all of this, 310 with parentheses around it and a space. This is separated with dots. There's no delimiters here. And then I've got things with 2 phone numbers. I've got a work and then a home, and they're written differently. This is separated by spaces, and this is separated by dashes, okay? And so when I run this, okay, string extract matches only the first match, and so indeed it pulls out this thing. It pulls out this pattern. It pulls out 310 with the dots. It pulls this out. It matches that. It matches that. Okay, it doesn't match the 123-456 because phone numbers cannot start with a 1. Okay, so that does not match. Okay, if I do an extract all, again, so here I've got 7 elements in my string, and sometimes we get 2 matches, like in this case where I have 2 phone numbers listed, and it matches both of them. The ones where it didn't match, like Apple and the 123, it returns back a character 0. Okay. By using match, I can extract out the elements, right? So this will just pull out the entire pattern that matches. Because I created capture groups, one around the area code and one around the phone number, it pulls those out. It pulls out the area codes, okay, and it pulls out the phone number part that matches as well. Okay, and so this is still kind of formatted. And again, string match all, it returns kind of a list, and then I can kind of iterate through the list. Sorry, I'm going through this quickly. So I iterate through the list to kind of just append everything together. Okay, and so we might be happy with this, but we might also look at this and say, I don't like how this one has a dash, this one has a dot, this one doesn't have anything, right? So we can do a replacement with capture groups, okay? And it's not as simple as just saying replace any dot with a dash and replace any space with a dash. Because here I have an instance where there's neither a dash nor a space or a dot, okay? And I just have 7 digits altogether, right? So I can't just say find and replace dashes, dots, and spaces with dashes, okay? So what I'm gonna do is I'm gonna say search for 3 dashes, and then this delimiter of a dash, space, or dot is optional, and then search for 4 digits. And that allows for the possibility that 7 digits are all together. Okay, so I say 3 dashes, or 3 digits, and an optional delimiter followed by 4 digits. I put these in capture groups so that when I replace the text, I can say use capture group 1 dash capture group 2. And so this is the text that comes in, and this is the text that gets output. So all the spaces get replaced with dashes, and also in this case where I have 7 digits together, get formatted properly as well. Okay? All right. I guess there's a couple slides left that I think they're straightforward enough that you can kind of read through them on your own. Okay? So we'll end there. Regular expressions, great stuff. All right. Have a good weekend. We'll see you guys on Monday.